Every forecast has error, but how much of that error is actually avoidable? At some point, we're dealing with variability that's essentially random, at least in the forecast horizon. We use models to define predictable reasons for variability, but what about that variability that sits beyond the model? For example, given enough data, a model would figure out that the best forecast for a pair of dice is always 7. However, even though we can make that absolute best forecast for each roll, over time we'll still see about 35% error. Of course, that's because each data point is random, but there's randomness in the real world as well. Let's look at how we can put this information to use. There's noise in a trend of dice rolls, but we have the math to define that noise. The variability of that trend is 35%. That's the same as the error from forecasting 7 each time. Let that sink in. The variability, which has nothing to do with the forecasting process, is the same as the best forecast error you can achieve. This relationship isn't just true for a pair of dice. It's true for any number of dice. And more important, this relationship holds up well with real-world demand. The implication is variability can serve as a benchmark for the performance of your forecasting process. If you have more forecast error than would be expected from the variability of your demand, it means the forecast process itself is creating error. That could be a model tuned to be too sensitive and creating erratic results, or maybe just too much guessing going on in manual inputs. Conversely, consistent low error relative to variability means your process is effectively picking up on expected drivers of variability, such as seasonality, trends, or good market intelligence. This allows us to look at error in a whole new light. Instead of just comparing products or sales reps on error alone, we can consider them in the light of how much demand noise they're up against. We also know from experience that product families generate less error than individual products. Now we have the math to see that reduction follows very expected statistical behavior. In addition to allowing better comparisons across products and organizations, this technique exposes a new way to improve forecast error. In many cases, forecast techniques only fine-tune the error. The coarse adjustment is in the variability. And the people that control the variability level are generally business leaders who are not necessarily involved in the forecast process. If you would like to dig deeper into this relationship between variability and forecast error and how it may be put to use in your business, reach out to the email shown below.